Now the problem statement. So now from this question onwards, our interview questions are getting started. Okay, so now our problem statement is this: convert an array into zigzag fashion. Now zigzag fashion is something like this: a less than b greater than c less than d greater than e less than f. Now input is 4, 3, 7, 8, 6, 2, 1. Output can be 3, 7, 4. You can see that it is following the condition a less than b but greater than c, which is still less than d. So 4 is less than 8 but greater than 2. 2 is less than 6 but greater than 1. How to convert this into this? Any idea? Anything which is coming into your mind, you can just speak about it. Or let's say brute force approach even. Any random guesses? Okay, so I'll tell you over here. So if let's say we don't know anything into data structures and algorithm, what we will do? What we will think is in which way it is getting swapped. So you can see that 3 is getting swapped over here. If you see 7 is getting swapped over here and 4 is getting swapped over here, and we see that is there any pattern into this, and if this pattern is uniform towards all the 3, a greater than b and c, a less than b greater than c, if this pattern is uniform across all the triplets, then we can apply this. But if you can see over here, the swapping pattern is not uniform. The swapping pattern is not uniform. Then what can we do? And do you think that this can be the only answer? It can be something like this as well: 1, 3, 2. Isn't it solving the problem? Then it should be greater than. So I'll write it down something like this: 8, or let's say 6, or the 8 was perfect, 8. Okay, instead of that, I can write it down something like this. One, 3, 2, then 2, 4, or 5, 4. Still, isn't it solving the problem? Yes. Then 4, 5, then 6, 8, sorry, 7, 8, something like this. This will also solve my problem. So there can be multiple answers for this, isn't it? So this also can be answer and this also can be answer. Now, do you think you can solve it? And if yes, what would be the way? So as I said, it is happening into triplets of a greater than a less than b greater than c, then c greater than d, c less than d greater than e, and e less than f greater than g. So this triplet, you need to make sure that it is happening. And as I said, there can be multiple answers. Is there any other way to do so? What is the first thing that comes into your mind when I drew this, when I wrote that this also can be an answer? Anyone? Divya, Rahul, Shakti, Somyata, Tanushri. Anything which is coming into your mind? Sorry? Yes, it's so we have still not written the code, so we cannot say that it's an order of n or order of n square.
Okay.
Right? But what my point is that, let's say if this question is given to you in an interview, what are your thinking pattern? I just want to know whether if it's, even if it's right or wrong, we need to come at a solution A, which is not at all optimized. And then we can reach to a next level solution, right? So that's why I want to know that what would be your thinking process.
No, so here the list or like the array which you have given. So
Yes,
it's like we know, okay, there is an element around which some elements are smaller to it and some elements are larger to it. Like,
yes.
is that a pattern?
Okay, so we are trying to see, is there forming a pattern? So this is what we did. That is it forming a pattern that if we swap just the first and third number or the second and fourth number, will it help? But we see that no, it's not helping. You see over here that in given example, the first element is getting swapped with the third. Okay, and the
Okay.
third and second are actually swapped, right? So if you see second and third are swapped or kept as it is, and the first one is taking its place of third. The fourth one is keeping it as it is, while fifth and sixth are swapped, and seventh one is as it is.
Yeah. So Dhaval, I have an approach.
Yes.
Yeah. So first, pick any element from the array,
Okay.
and like like pick the second element from the remaining elements and check if it is greater than the first one.
Okay.
If it is greater than, just leave that element and go for the third element, and pick the third element from the remaining elements and check if it is less than the the second element, and which goes on. Like it's like a backtracking algorithm.
Okay. So in that, what will happen? So in case what you are doing is you are just comparing two, A
Yes.
and B. So what will happen? Let's say. So let's take in some such kind of example. Let's say you have something like this: 1,
Hmm.
2, and 0. So what will happen? 1 is less than 2. You'll keep it as it is. Then you will compare this 2 and 0. It is happening, or like, okay, let's say 2 and 0. That still makes sense. But what my point is, if it requires a swap, let's say it would have been 4. Okay, if it requires a swap, what if it requires this with the swap with the previous one as well?
Okay.
Okay, so still now, till now, we think that it may work, it may not work, because with one example that we have taken, it's working. With another example that we can think it may not work. So we will try to do so. But before that, as I said, there can be a multiple answer with this. We can think that why not we can, sort it. With array, as I said, what you can do max is, so one more thing, guys, that with the array, we'll take all the questions right now, which are not getting solved with a stack or heap or dynamic programming initially. When we'll take the stack, we'll solve the same array questions with the stack, some array questions with the stack. When we'll take the heap, we'll solve the heap problem, and then we will solve the array questions which can be solved with a heap. So right now you can assume that yes, it cannot be solved with any other data structure, or it may not be, right? But yeah, algorithmic way can be. So as I said, that this can also be the answer. You can see that they are almost sorted: 1, 3, 2, 5, 4, 6, 7, 8. Right. So if this also can be an answer, we can think about why not to sort it. So let's say from array, if I have sorted it, I can see that 1 is as it is, because 1 is less than 2, because this one would be the smallest one. And to make this equation 2 greater than 3, it won't happen. So we just swap this 2.
Yeah.
So what will happen is 1, 3, 2, and our equation seems working. Make sense?
Yes.
And we'll see that, yeah, A is less than B is greater than C is happening if we swap 2 and 3. Now, once it is done, we found it out, it is 1, 3, and 2, and it is working. We'll go for the next 3 elements. So when we go for the next trial, we know that it should happen for this 3, which was ABC and CDE. So we'll go for the CDE. So again, if we go for the CDE, we can see that C is less than D, the way A was less than B. The C is less than D as it is, and D and E should be swapped. So if they are swapped, the answer can be 1, 3, 2
5, 4.
and 5, 4. So it seems working. right? And then we'll go for the next trio, 4, 6, 7. So again, 4 will remain as it is, and 7, 6 should be swapped. Right? Make sense? Now,
Yes.
if we go for this kind of approach, what would be the time complexity?
Big O of n.
Why do you say that?
Because we are traversing. We are sorting the array first, right?
Exactly.
So yeah.
So when we are sorting our array, the sorting complexity. So when we'll take the sorting algorithm, we'll discuss about what is the sorting complexity and why it is this much sorting complexity. But the least the sorting complexity is
Big O of n log n. Yeah.
big of n log n. And then plus what you'll do is you'll iterate over the array and you'll swap in between, right? So
Yes.
what you'll write some function 4 and you'll just swap some array elements, something like array of I with array of I plus 1. Now this computation, you can think about it. Okay, if I is less than, if A of I is less than A of I plus 1 and rest of the things that we can think about it. Okay, but my point is such kind of for loop will take order of n plus order of n log n. So our total time complexity is order of n plus order of n log n, which is order of n log n, right? Which is order of n log n asymptotically. All right. So obviously this approach doesn't seem that much better. Can we do it in order of n? So we'll see in this way. Let's say, I think someone said that we can take 2 elements together, this 2, then this 2, and then we can see will it work or not. Okay, so for first example, it was working. We'll try to find it out some other examples, and then we'll see whether it's working or not. So as we can see, 4 and our desired is A less than B, greater than C. This is our desired one. So if for the first couple A and B we are thinking, then A is less than B, no, then swap it, we make it 3 and 4. Okay, then our array will be, so let's say then we move further again, then our operations is greater than. So first we tried for less than, now we'll go for greater than. So is 4 greater than 7? No, then swap it. So 7 and 4. And my now array is this. Then I'll take this as A and next 8 as B. Is my 4 less than 8?
Yes.
Yes. Need not to worry. We'll go for the next one where A is 8 and 6 is B. Is 8 greater than 6?
Yes.
Yes. So we did not to worry. And we'll make A is a 6 and B is a 2. Is 6 smaller than 2?
No.
No. We need to swap it.
Yes.
So we swap it and we find it out it's a 2 and 6. Now my point is the way we previously thought, will it work or not? So now my point is, do we need to check it for backtrack? Do we need to backtrack?
Yes.
Why so? See, okay, yeah.
Actually, I didn't get this thing this time. Like the explanation which you gave for 2 elements, picking 2 elements and then other 2 elements. Can you explain it again?
Sure. What I'll do, I'll erase the whole, this one.
Is my voice audible?
Yes, your voice is audible. Okay. So what I'll do is I'll erase this part. Okay, and I'll explain it again. So, so far those guys who understood it, they can do one thing. They can see that whether do we need to backtrack or not. So, Divya, what our part was that we have 2 operations. One is less than, another is greater than. So if I'm
Okay.
right now doing operation 1 less than 1, so what I'll do is I'll say two pointers in the sense a of I and a of I plus 1. Okay.
Okay.
And I'll see for this one operation. If a of I, that means a is less than b. Now you see, is it not? Right?
Okay.
So to make it happen, what I'll do, I'll swap those both. So if I swap the values of those both, what will happen? 3 and 4.
4. Correct.
Correct. So now is this holding true that a is less than b? Yes,
Yeah.
a is pointing to 3, b is pointing to 4. So now it makes sense
Okay.
that this equation a less than b is holding true. Now, next one is, so my equation was something like this, a less than b greater than c. Okay, so now if I make 4 as a
Okay.
greater than as an operation and 7 as b, now can I
Okay.
do the same operation? So my operation was less than previously, now my operation is greater than. Can I again check the same thing, that if a is greater than b,
Okay.
and you see that no, it's not, so what you will do, you will swap it.
Swap. Correct.
So you swap it and you find it out 7 and 4. So finally your array is 374. Now your 374 and rest of the elements as it is 8621. Now at least for this trio, is it holding the same equation, a less than b greater than c?
Correct.
Yes, it is. Right? And
Okay.
what we'll do, we'll continue the same process, because last time this b was the one. Now we'll make those as a and next element as b.
Okay.
And we'll try to see that again, previously it was less than, now it was greater than. Again for the less than, will it work or not? Because next you'll have to do for less than, e greater than f less than g greater than h, right? That should be your final output. Make
Correct.
sense?
Correct. Yeah.
Correct. So in this way, what someone suggests, in the same way we are going in a pair. Now what my point was, when I swapped with 4 and 7, do I have to check it for the previous element? Like,
Because
do I have to
it will
backtrack?
satisfy the condition.
Exactly. So mathematically, if something is holding true, something like this, a less than b less than c, can you say that a is less than c?
Correct.
And you can also say that b is less than c, right?
Yes.
And same thing goes for this. If a is greater than b and a is greater than c, you can say that yeah, a is greater than c, right? So the same thing happens over here. When you know that 3 is less than 7,
Okay.
right? And
7
the
is
next two elements are something like this. Let's say,
yeah.
okay, so the example which I'm taking, let's say it has something like this, 4, 3, and 1. So I'm just thinking, will it help or not?
Yeah.
So let's say 4, 3,
In
and
that
1.
case, those elements is smaller to the both.
Yeah, so I think if it is a reversely sorted, then it won't be.
Yeah. In that case, it won't satisfy the condition.
If 4 is less than 3, okay, so what you'll do, 3 less than 4 and 4 greater than 1, you will make it and you will go away and you will make it what? 1 and 8. Yes, I think even in this case, you don't have to worry, because see, even if I'm taking this as larger, 3 and 7, or I'm taking such kind of example, 3 and 1, a smaller, it doesn't affect my algorithm. Otherwise, the output would be 3, 4, 1 and rest of the element, right? I think Rahul had this, Rahul and Soumyadhar, I think you guys had the similar approach, and we were thinking that do we need to do backtrack? So we took both the kind of example in which are this element, which is next one, is smaller and also greater. But in both the cases, we don't have to do backtrack because the mathematical formula, as I say, if it is one time A less than B less than C, or A greater than B greater than C, you can say that A is less than C and A is greater than C if it is holding true. So because of the same reason over here, because 4 is less than 3, and once you swapped it, the next element, if it is smaller than that, it will be always smaller than 3. You don't have to worry about that, right? Correct? So as we say that we took both the example and we understood that backtracking is not required, we can see that if we just do the swapping by 2 elements, it can be done. It can be done. So what we so far understood is that we need to see for the operation less than and then for the greater than. Okay, so we can understand that we need to switch between this both operation. So one time we need to do this, another time we need to do this. So that is one observation. Second observation is that we'll check if A is greater than B, then what we need to do. Else if your operation is greater than, then we'll check A is greater than B or not. Sorry. So over here, I'll just make some change, small change. If your operation is smaller than, then you will check that if A is smaller than B, and then you swap it if it is necessary, and else if your operation is greater than, again you check if your A is greater than B, and then you do if the swapping is necessary. And then you move what? Then you move A of I. So I you can increment. So something like this we can do. What we can do is whatever the previous whatever the previous B was, we can make it as A, and new A, sorry, not this. Whatever the previous B was, we will make it as A because it's the right side operation, and the new B can be A of I plus plus. So these are the three operations that we need to do. One thing is switching, checking between this. Second thing is switch condition, if it is required. And third thing is assignment operation. So initially the A is this and B is this. Now B equals to A. So for the next time in loop, your A can be this and B can be this. And again, next time your A can be this and B can be this. And the same operations should go on. So now if we convert this part into code, it's very easy, and it can be written something like this. We are writing one operation is equal to false initially. When false means this one. Because we need to switch, you can just write it down something else, 1 and 0 as well. And true is equal to this. So operation equals to false. For I equals to 0 to I less than n minus 2. Now why I did for n minus 2? Why? Because at the end, your A and B should be up to this only, right? It should not go further, because if you do I plus plus to assign it, so what will happen? You'll assign A over here and some null pointer towards the B, and your code can be giving runtime error. Instead of that, we are running just up to this, and at the end A and B would be at the same place where it is required. Then we want move further, right? We want move further. That means we want to go for A equals to last number and B equals to A of I plus 1, which is out of the boundary. So that's why we have written I less than n minus 2 I plus plus. If operation, if it's a less than operation, as I said, false was, sorry, greater than operation, we check if A of I is greater than A of I plus 1, which is this 2, AB. If yes, we swap it. Otherwise, if the operation is less than, then we check if a of I is less than a of I plus 1 and we swap it. And we move further. When we move further, our I is incrementing. So what happens is our I is at 0. We check for 0 and 1. And then again, my I is at 1. So we'll check for 1 and second index. And then we'll check for 2 and 3 index. Easy?
Yes.
Simple and easy?
Yes.
Yes.
Okay. So what would be the time complexity for this?
Big O of n.
Simple, big O of n, because it's running for order of n times into this. And this all elements or this all operations are in order of 1. Simple. Okay, we'll go for the next question. Before that, if anyone has a doubt, just do let me know. Okay, so from this simple question, we'll move on to the next question. So the problem statement is this one. Given two sorted array and a number x, find a pair whose sum is closest to x. So we don't have to find a sum, or we don't have to find a pair whose sum is x. We need to find a sum. We need to find a pair whose sum is closest to x. Make sense? Let's say if we have an example, we'll take an example and we'll understand that we need to find a pair, one element from I, first array, another element from another array, such that the absolute value or the difference between a plus b minus x is minimum. That's why it's called closest one. If we take an example, this can be the one. If a is 2368, and as we say, it's a sorted array. It has been given to us, it's a sorted one. If a is 2368, b is 10, 20, 30, 40, 50, the answer can be that x is 34. The closest is 3 and 30. How to go for this? If this question is asked to you in interview, what are your thoughts? So what do you think if this question is asked to you in interview? Let's say brute force one. What do you think? What would be the brute force approach?
Like pick all the elements from A and B and check the sum.
Okay, pick all the elements.
Like
Okay.
Single elements at a time, like 210, 220, 230,
Okay.
and 310, 320, 330.
Okay. And every time we find it out the minimum
The minimum,
difference,
yes.
and we do it. What
Yes.
would be the time complexity for that?
Like big O of m into n.
Exactly. Big of m into n. Whatever the length could be. If the length are same, let's say both are of n length,
square.
it's order of n square.
Yeah.
If they both are different, it can be order of m into n. Exactly, correct. And as you see, it can be done with this way. The 2 into 2 with 10, 20, 30, 40, 50, then 3 with 10, 20, 30, 40, 50. Now, given that they are given a sorted one, we can take the advantage of those. So let's say something like this. If we just go with this, as I say, in array, it can be only few ways that you can either start from first or you can start from the back. Right. So let's say you are starting from both the first. So you find it out 2 and 10. The difference is 34 minus 20, which is something larger. Now you don't know which pointer to move further. Right? Which pointer to move further means either you can check 3 and 10 or you can check 2 and 20. If you check both, it will be again order of m into n. So you need a strategy for that to reduce it. Right. So let me give you another example with just different way. Let's say there is only one array. 2, 3, 6, 8, 10, 20, 30, and 40. Now, if you have to find it out the same, what you will do? You want to do for 2 to 3. Why? Because you know that 2 and 3 cannot reach to 34, right? Or very close to 34 even, right? What you know that if you are starting from 2, you need to start from 40, because 40 and 2 sum, which is 42, can be closest to 34, right? Simple or not? Then you can decide 42 is very large. Then you can say that either I'll reduce it if it is being smaller. So something like this. Let's say if you are at 20, let's say the example is given to you is this. Okay, if the example is this one, then your sum with I equal to 2 and j equal to 20 is 22. So you know that 22 is less than 34. So you have to increase this sum to reduce the difference. Difference between 34 and 22 is, let's say, x. And if you want to reduce the x, what you need to do is increase the 22. And if you want to increase the 22, you need to increase the number 2. Because 20 plus 2 was there. So you need to increase the I. So that's why you'll increase the I in this case. Right?
Yes.
So if your sum is less than x, you'll increase I plus plus. If your sum is greater than x, you'll reduce j minus minus. It was in the previous case 30 and 40, right? It was in the previous case. Now we just have one difference, is that we have two different arrays. Can we apply the same mechanism over here? Let's see. If we see that the same array 2 and 50, as I said over here, I'm using the 2 pointers approach. One is starting from the last and another starting from first. Over here I'm doing the same thing. Instead of taking it as in a singular array, I have two arrays, and what I'm doing is I have 2 which is pointing to I have I which is pointing to 2, and I have j which is pointing to the last of b. And then I'll see 50 plus 2, 52. The absolute difference is 18. Okay, and which is large? 52 is large than 34. Then that means I have to reduce the j. So I'll reduce the j. Again, I have 40 and 2, 42, which is greater than 34. I'll say that, yeah, difference is 8. Previously it was 18, difference is 8. But it is still greater than 34. So I'll reduce it to 30. I reduced j to 30, and see 30 plus 2, 32. The difference is 2, but the sum 32 is smaller than 34. So the approach which I took over here, if it is smaller than that, I need to increase it. So what I'll do, I increased it. And then I found it out 33. The absolute difference is 1. 33 is smaller than that. So I'll find it out that again the difference. And I found it out that now the difference is 36. Now if I reduce it, it will be 26 and 18 and so on. But if I keep the minimum difference, the so far minimum difference was 1 with the two numbers 3 and 30. With the two numbers 3 and 30. So it seems this approach will work. Now if I have to code it, isn't it easy to code? As you can see, I have written a pseudo code, something like this, for I equals to 0 to I equals to 0 and j equals to m minus 1, which is pointing to last element, which is the largest one, and it is pointing to the first one. If we consider it as in a single element, single array. And then I'm looping I less than n and j greater than 0. You can still do optimization, okay, into this. If absolute difference of array of I plus array 2 of j minus sum is less than difference, we just update the difference and we move ahead. And then we see if array of or a of I plus b of j is less than some I plus plus else j minus minus. Something what we did so far in the previous examples.
I have one point actually.
Yes.
Yeah, so basically in the example which you have given, you have the first array as all the elements are lesser than the second array basically.
Yes.
So,
Yes.
so basically if they're like in this example it's like that. So if you merge both the arrays will be sorted in the ascending order, first and
Yes.
second array. But if
Yes.
we have a different example where the second array elements are not larger than the first array, then
Exactly.
so how will the solution work in that case?
Okay. Let's take an example over here in the same way. Okay. Let's say what is the last slide. Okay. This is the last slide. Over here, I'm taking the similar example which you say. So let's say I have an array something like this: 1, 3, 5, 8. And then I have something like this: 2, 4, 6, 7, 9, and 12. Is it fitting our scenario?
Yes, I think.
Yes, right?
Yeah.
Now, again, let's say we take a simple case. Let's say 5 plus 7, which is 12, and we take x equal to 13. Now we'll see, will the same approach works or not? Okay. So right now we are just validating what you suggested is exactly the same, exactly the right one. Let's say, so 12 plus 1, which is exactly 13. So let's move ahead. Let's say we have 14 as an x. Okay, so x is equal to 14. 12 plus 1 is 13. So as we know that 13 could be the very nearest one, we mark the difference as 1. And as it's a sum is 13, what we need to do is increase the I. Now our I is pointing to this 3. 12 plus 3, 15, which is greater than that, will reduce it to j. 9 plus 3, 12, which is smaller. So to make it large, will increase the I. 9 plus 5, which is 14. Again, 9 plus 5 is 14, and it would be the nearest one. Let's say if it is the answer, right? And again, if we do the same thing, let's say if it is this, if we again follow the approach, we will increment the I, continuously decrement the j, and then we find out that minimum, the difference was for the pair 9 and 5. The difference was 0. And we see that yes, the similar approach works. Why? Because actually will traverse both the arrays element all once, right? So all the elements would have been traversed once minimum. So we'll check all the possible pairs, not all pairs, but all the possible pairs which can form nearest to 14. Correct. So even if it would be over here 18, the same formula would have worked. Why? Because at some point of time when your I is at 18, your j would be smaller. Right. So what my point is, yes, we are checking the pairs, but we are not checking all the pairs. We are trying to check all the pairs which has sum which is very nearer to 14. And that's why we have this kind of approach in which I is incrementing and j is decrementing. And whatever the kind of array we take, yes, it will help given both the arrays are sorted.
Question is like equal to x, then we have to check, have the both the arrays like that, merge the arrays and then do that, right?
No, we don't have to merge it, even if they are both different.
Like suppose the question is changed basically, instead
Okay.
of we have to find the closest to x, we have to find the two elements in one element in each the array where the elements sum of the elements is equal to the x.
Okay.
In that case.
So you are telling that if we have given only one array and we need to
Yes,
find it
telling
out.
that we are giving both the arrays, only the
Okay.
question. Can you go back to the question once?
Yeah, got it. I got it. That
Yeah.
what you want to do, instead of a closest, sum is equal to
X. Yeah.
Sum is equal to x, right? Again in the same case, our approach will be the same. Okay, why I would say that? Let's say the same example with x equal to 33. You know that this will work. The same example will work, right? The same example will work.
Yes.
Even if we take the different example, why this approach will work is because, let's say over here is if x is equal to 14, this approach was working. Why? Because we are not checking all the pairs. What we are checking is possible pairs. That means one element smaller, one element larger. Correct? Which can possibly be nearest to x or can be x. In our case, can be x. If it is not x, then if it is smaller than that, so let's say the same example I'll take again over here, 1, 3, 5, 7, 8, and what I have taken 2, 4, 6, 7, and 12. Okay, and your x is 14, 7, 9, and 14, and you need to find out the sum, a pair whose sum is exactly 14, right? Then also the same approach will work when where your I is starting from any of the first elements smallest and j is starting from the largest of another array. Now why will it happen? It will happen because your I is the smallest and j is pointing to the larger element. Its sum will be the closest to x, can be the closest to x. If it is not, if I plus j is smaller than x, that means that this can be the largest one. Can be. I'm not telling it will be. It can be the largest one. So what we are doing is we are incrementing I. That means we are increasing the value which is pointing towards the from the a of I. That's why as it is less, we are trying to go near to x because I would have been incremented. If it is greater than j, if I plus j is greater than x, that means we are going further, something like this, let's say 12 and 7. Then we are going ahead of 14. That's why we'll try to reduce it. So this number is already small. This number we have taken large. So that's why we'll reduce j minus minus. Makes sense? And that's why if the pair is there, in our case it's 5 and 9. If the pair is possible, we will find it out.
Dhaval, what if the arrays are not sorted?
Okay, if array is not sorted, then what should have happened? Then you cannot take the opportunity of this sorting ones, right? That these are sorted one, and that's why I'm taking the largest one. This can work because one is a small and one is a larger element. One is a smaller, one is a larger element. If they are not sorted, this cannot be done. Then you need to find it out some other approach. We'll see just after that. Okay. But if this approach is clear, let's go ahead and see the pseudocode, and then we'll think about the code. But so far, Tanu, I think Tanuja had this question, right?
Yes.
So far, it's clear, right?
Yes.
Okay.
Yes. Thank you.
Thanks. So we have seen that in this way our logic should work. Now, if we have to code it, is it very easy to code? Can you guys try it out? Or should I explain once the code? Okay, let me code it. Let me see the way it is coded. So let's say print closest is the function. I'm given two array, array 1, array 2, let's say A and B. The length of those both n and m. Okay, difference initially I'm making it very large so that if I find a minimum distance, I can update it. Okay, now while I is less than n and j is greater than 0, I need to do this performance operation. Now why I have to do for the full? Because the question which Tanuja asked, it can be that the J over here is not the largest one. The largest one can be represented by I as well. And that's why to do so, we have to go till J is greater than 0 and I is less than N. Correct? So once we understood in which way the loop should go, now we'll see the operation which we have described over here. So loop is done. Now the operation. If absolute of array of 1 plus array of 2 of J is less than minus X is less than difference, we'll update it. Okay, we update the difference, that this is the minimum difference. And if it is the minimum difference, we'll keep the indexes result of I and result of J. And then we'll update the I and J pointers, which is like this. If array of I plus array of array 2 of J is greater than X, J minus minus, else I plus plus. And then we can say that the closest pair is this. Simple. Again, the time complexity is order of n. There is no space complexity for this. Right? So far clear, everyone?
Yes.
Yes. Okay. Okay. Now, instead of this, there is one more point which someone asked. What if these are not sorted? So let's say instead of not sorted 2 arrays, I'll say a single array. Let's say 1, 12, 3, 8, 4, 16, 9. Now in this, if I have to find it out, the pair which is closest to X or equal to X, what I have to do? I cannot use any of the property. I cannot say that I'll start one pointer from first and another pointer from last, because which pointer to increase? There is no rule for that. If they are sorted, then there was a rule. If they are not sorted, then there is no rule. So which pointer to increase? No, I cannot. So what you can do is, either you can do is find it out all the pairs and you can do it in order of n square. Correct? Simple one. Now, if you don't want to do it in order of n square, remember one thing, that the time complexity is always reversely proportional to space complexity and vice versa. So if you want to reduce the time complexity, you need to increase the space complexity. So in the last, so over here, nothing can be done. So if you want to reduce order of n square to n, you need to increase the space complexity. So what you can do? Now, what problem is happening because of that order of n, order of n square, our code complexity is going. So what is happening? We are taking first element I and we are running through all to find it out if it is equal to some number. So what happens is, let's say if x equal to 17 and we want to find it out equal to 17, x equal sum equals to 17 of the pair. What happens is, we want to find it out 16, and to find it out 16, what we have to do is we have to traverse the whole array. We have to traverse the whole array. What if to find it out 16, because 16 plus 1 can happen 17. So to find it out in the case of 1, the next element is 17, which is 16, which is 17, which is x minus a of I. And this number, to find it out, what we are doing is traversing for the rest of array. Instead of traversing for the rest of array, can we have it into order of 1? If we can have it into order of 1, our time complexity can be in order of n, right?
Yes.
Yes. So how can we have time complexity in order of 1 to search any element?
Using hash map.
Exactly, using hash map. So when you use hash map, your space complexity increases, because you will store the whole array into hash map, and then you will say that whether the 16 present into this, yes or no. Yes, then move ahead. No, then don't move. Right? And in this way it can be done. If the question is still that need to find it out the closest, then it cannot be done. Because in this case, you can use the hash map in the only case where you have to find it out the exact value, not the closest one. Right? And that's why if you have to find it out closest in unsorted array or multiple arrays which are unsorted, you cannot use hash map, or you cannot use this. The minimum time complexity is order of n square. No, it can be order of n log n as well.
Yeah.
Because you sort it and then do it.
Yeah.
Right? So these are the ways it can be done. So if you have to do it in order of n, you have to use space. Otherwise, order of n log n is always there. Right?
Yes.
Yes. Now in assignment, just make a note of it. I'm just giving you an assignment over here in a code of, over here I'm writing it down. You have an assignment. Before the next class, you'll have to mail me. Okay. In that, you have the same question, but you have 3 sorted arrays. Okay. And you need to find triplets from these 3 sorted arrays whose sum is closest to x. The approach will be the same, but when to increase I, when to increase j, and when to increase k is something that you have to derive. Okay, understood the assignment?
Yes.
Everyone? Sure?
Yes.
Okay. So next session will be on Thursday. Before that, you'll next session will be on Wednesday. Before that, you'll have to submit it. I will move on. Before that, is everyone okay or everyone tired? Then we can take a break. Then we can come again, or we can go ahead and we can start the next question. Whatever everyone says.
Till what time you are going to take?
So generally we go for 2 hours, 8:30 to 10:30. If you want to take a break of 5 minutes and come back, yes, go ahead, come back. If you want to stop over here because it's the first session, it's fine. We can take it up the rest of the questions into next session. Whatever you wish. It's fine. See, everyone can speak, everyone can put up their opinion, no worries. Okay.
So we can continue it's my
Okay.
opinion. Yeah.
Okay.
Yeah, I
Sure.
also think we can continue.
Makes sense. Sure. So 2 people spoke up. They say continue. Let's continue. Okay. Let's continue for the next point. Next question. Next question is the count of subarrays. We need to find it out the count of subarrays whose maximum element is greater than k. I'm muting Soumya. Okay. Okay. So we need to find it out the count of subarrays whose maximum element is greater than k. So we have been given a k. We have been given a we have been given an array, and we need to find it out the count of subarrays. How many subarrays are there whose maximum element is greater than k? So if we take this as an example, okay, our answer is 3. Now, how the answer is 3? Let's see. If 1, 2, and 3 is an array, the number of subarrays can be 1, 2, 3, 1, 2, 2, 3. Now you see 1, 3 is not a subarray. Correct? 1, 3 is not a continuous subarray. It's subsequence. Subarray is continuously elements which are side by side. So for one length subarray is our 1, 2, 3. Two length subarrays are 1, 2, and 2, 3. Then three length subarrays are 1, 2, 3. So these are the subarrays. Now out of those, how many subarrays are there whose element is greater than k? It's strictly greater than k, not greater than or equal to, greater than k. One subarray has greater than k. Another subarray has one element greater than k, and there is a third element, third subarray whose maximum element 3 is greater than subarray. Now, what would be the simplest way to achieve this answer or to solve this problem, or what comes into your mind when this question has popped up into screen, or consider it as this question is asked to you in interview?
Hi, Dhaval.
Yeah, hi.
Shakti.
Yeah, sure.
So sorry, I was on mute most of the time. I'm in office actually.
Okay.
Uh, so can we go back to this? I think there is a mistake regarding that log n and n by 2, that time complexity. I
What's
equal
it?
to I equal to that for loop. I equal to I into 2.
Okay, yeah, I think we discussed it when it was I into I multiply by 2.
No, I think it is still log n. I into multiplied by 2 is log n, not n by 2 times.
So let's say it happens in this way. 1 multiply by 2, 2, multiply by 2, 4, multiply by 2, 8,
Yes.
multiply by 2, 16, then 32, then 64, then 128, right?
This is log n.
256.
Yes. I into 2 is log n.
Okay. And where I square, which is I, so
I square.
2,
Let's start from 2.
4,
4.
16,
Hmm.
then
256.
256, and then done, because our value was less than 100. So I agree, 256, 512, and 1024 won't happen. So if your I is equal to 1000, your values would be 10. 1, 2, 3, 4,
10.
5,
Yeah.
6, 7, 8, 9, and 10. Yes.
That is log
Then
n.
in this case, it's order of log n. In example, actually, what I did was 2, 4, 8, and then I stopped it. And that's why I thought that it is just using all the even numbers. And that's why I said that, yeah, it's going ahead this way. Agree.
Is there any term for the second series?
It's a square series. That's what you can say, but it's not any of the arithmetic progression or such kind of series. No, there is no some name of that.
So it is even asymptotically lower than log n.
Yeah, it is asymptotically lower than log n because it's just 4 elements.
Yeah.
As you can see that.
Okay.
You can say that order of root n, but I don't see root n as well. Root n
Root n is something
is
else.
10, which is
Yeah.
very similar to log. That's what. It's something different. It won't
Yeah.
be to 10. It will be into
Because root n is bigger than log n.
bigger than log n. Yes, it is bigger than log n. That's what I was thinking. But no, there is no approach for that.
Yeah, no term for that. Yeah.
Yeah. Thanks for pointing it out. Okay, so initially I was right, but then I took just the odd numbers, and then I was saying, okay, yes, it might be my mistake. No worries.
It's
Okay.
because of the lesser number of elements you wrote.
Elements, yeah, I took just few elements, 4 elements, and then
yeah,
I took
that's
like
this.
okay, lesson learned that you will always have to think for n equals to 1, then up to n equals to 4, 5, at least. Thanks. Let's see for this question. So far, is it clear that in this way the subarrays are? Now, if we have to solve this, what is the first thought that is coming into your mind? How will you solve it? It's for everyone.
So the brute force or the most basic way I think one can think is compute all the subarrays and then look for the element.
Okay. So the simplest way exactly that you are telling that print all the subarrays or find it out all the subarrays and then do it. Let's see in which way you can code for it. Sorry, my PPT's got corrupted. I'll write it down. No worries. So it can be in this way that you are writing it down in this way. For I equals to 0 to I less than n, I plus plus. Then for j equals to I to j less than n, j plus plus. And for k equals to I to k less than j, k plus plus. You are printing your array. So what happens is for I equals to 0, your j is equal to 0. So that means your answer is 1. Then I equals to 0, j becomes next. So once it is done, I equals to 1 and your j equals to 1. So then you will print 1 and 2. So in that way, you will print all the subarrays of length 1, 2, and 3. So if I say it can be something like this 1, 1, 2, 1, 2, 3. Then when your I is equal to at this 2, you'll print j equal to 2, then j equal to 2, 3, and 3. And when you are printing into the k, you can say that you can just instead of printing over here, instead of printing, you can find it out if this subarray from I equals to k equals to I to k less than j, if the largest element is smaller or equal to k, greater than equal to k. If it is that, then you can increment the count. So something like this, you can increment the count. So over here, count is not incremented, not over here. When iterating over this, you found it out that one element is greater than 2. You make the count equal to 1. Over here, 2, and over here, 3. In this way, it can be done. But now, if you see that for some larger picture or some different array, you can see that those are some of the subarrays. If k is equal to 2, then all the subarrays which doesn't have the larger element doesn't have all the elements which are greater than 2. Can we think about solving the problem in this way? That we think that can we rule out this so that, let's say, we have some mathematical equation with which we can find it out what are the number of total subarrays. Okay, let's say if we have, and yes, we have some equation with which we can find it out what are the number of subarrays. And then if we can rule out all the subarrays which are larger than that, or we can just accommodate all the subarrays which has all the elements or any one elements which is larger than 2, will it solve our problem? Then we think, yes, we can do it. But how? That we don't know. But one approach can be this, right? Because
Yes.
apart from brute force approach, there is nothing that in this array we can do. So let's take another example and then see it. So let's say we have an array 3, 4, 1, 2, 5 and k equals to 2. We have just these 2 subarrays for which the elements are not larger. We have this subarray 3, 4, 5 for which the elements are larger than 2. Then 2 length element, 2 length subarrays 3, 4, 4, 1, 2, 5 larger than 2 and the rest of them. Now if we count it, if we can understand that it is 3, 4, 5, 3 plus 3, 6 plus 3, 9, 10, 11, 12, 13, 14, 15. We have 15, which is this equation. 5 into 6 by 2, which is 15. So it's a mathematical formula the number of all subarrays are actually equals to n into n plus 1 by 2. So we know that we can find it out total number of subarrays mathematically given the n. How can we reduce this 1 and 2, this subarrays? What can be the thought process for that? Anything which is coming into your mind?
We can try to find the numbers which are less than 2, less than k basically.
Okay.
And or maybe the other way, we can try to find the numbers which are greater than 2, and from their position we can try to find out which all subarrays they will be part of.
Okay. So let's take such example. Let's say we find it out all the elements which are less than or equal to 2. So number of elements are 2, 1 and 2. So with 2 elements, how many subarrays can be created? 2 into 2 plus 1, 3 by 2. So that is 3. So which is this 3?
Oh.
So if we just reduce all the elements which are less than 2, will it work? Let's see for the different example. Let's say we have k equals to 3. So one approach which you said is working for k equals to 2, and this example, we'll see if with the k equals to 3, does it work or not? Okay. So over here we have k equals to 3, right? And we remove all the elements which are less than or equal to k. So 3, 1 and 2. So we have 3 such elements, 3. So total number of elements, total number of subarrays which can be created by this is 4 into 3, 12 by 2, 6. Is it the same one? No. Why? Over here, with this 3 element, number of subarrays are 6, but we have just 3 over here. What went wrong? So what went wrong is the 3 is not part of the subarray 1, 2, right? The 3 is a different subarray and 1, 2 is into different subarrays. Now you see why our answer was wrong, right? We can apply for the subarray when the whole array is there. So if 1, 2 and 3 would be together, then the number of subarrays would have been 6. But 1, 2 and 3 are not different. They are at different position. That's why all the subarrays which are having values greater than 3 are this: 4 and 5, 3, 4, 4, 1 and 2, 5 of length 2, 3, 4, 4, 1, 1, 2, 2, 5 can be the subarrays of length 2, and out of that 3, 4, 4, 1 and 2, 5 are the subarrays whose length, whose maximum element is greater than 3. The 3 length subarrays are 3, 4, 1, 4, 1, 2, 1, 2, 5, and all of them has one element at least which is greater than 3. Then the 4 length array are 2 and 5 length array are 1. Such kind of subarrays are there. So we understand that we need to find it out, the subarrays which are smaller than 3, which are smaller than k, but which are continuous. Something like this. Over here we found it out the length of subarray 2, and then we found it out all the subarrays can be formatted from that, and from all we reduce that, then we got the answer. Over here what we need to do is we need to find it out all subarrays which can be generated from 1 element 3 and 2 element 1, 2, and we need to reduce it from it. So if you see, all the subarrays can be generated from 3 is just a 3. All the subarrays can be generated from 1, 2 is 1, 2 and 1, 2. And then from total, if we reduce it, we can have our answer. Now does it sound that it can lead to the problem solution? Yes or no? Everyone, have you understood this thing? Yes or no? Or I'll take another example. Rahul, Tanuja, Shakti.
I understood. I think it will work. I'm trying to think of a way when this will not work.
Okay, okay,
But,
makes sense. Rahul, Soumyadar, Tanu.
Yeah, I understood all.
Okay, okay. So again, I'll take one example in which the continuity, I'll take an example in which this 3, 4 are reversed. Let's say we have this 4, 3, 1, 2, and 5. Okay. Now, if I again remove all the elements which are less than 3, which will be 3, 1, and 2. The number of elements are 3, and the number of subarrays will be 6, 3 into 2, 3 into 4 by 2, which is 6. And which are this? 3, 1, 2, 1, 2, 3, 1, and 3, 1, 2. Right? And these are 6. Why it is working? Because these 3 are continuous. Right? So we understood from this 3 example that we need to find it out, not the length or the number of values which are less than 3, but we need to find it out the continuation of elements which are less than 3 or which are less than k. And then we need to find it out the subarrays can be generated from this, number of subarrays can be generated from this, sum it and reduce it from total subarrays count. Make sense? This we need to do. Correct?
yes.
So we have taken the another example where it seems working and then we understood it. Now my point is, what can be the simplest algorithm for that? Simple algorithm, loop from I equals to 0 or I equals to 0 to n. Remove elements which are greater than k, but just directly do not remove it. Count the contiguous element which are less than or equal to k, which we did over here, 1 and 2 which are continuous. 3 is smaller than that, then all the continuous elements which are less than k, we need to count it out. And then find it out the number of subarrays which can be generated from that. And then remove it at the end, remove it from the total, right? So if there could be one answer, that could be one example over here, which can be this 3, 0, 4, 3, 0, 1, 4, 1, 2, and 5. We need to find it out this 3, 0, 4 and count the total of subarrays. 1, 2, find the total number of subarrays and sum it this both, and let's say small s. Reduce it from the total number of subarrays n, which is small n plus, which is equal to small n into n plus 1 by 2. Right? So from this, we need to reduce it. This is our algorithm. And calculate its subarray and the continuous loop. Okay. So now, once we did this, now let's start writing down the code for that. So the code for that can be simple. The first step was to write down the loop. The loop can be written in this way. Simple one. Okay. Now, what we need to find it out is we need to remove all the elements which are greater than k. So we say if array of I is greater than k, continue. We just remove it. We just remove it. Now, all the elements which are smaller than that, if it is not greater than that, rest of the thing we need to do over here. If it is not greater than k, if it is smaller than k, what we did for this case was We need to find it out all the elements continuously which are smaller than k and then process it. So we find it out if it is larger than k, just forget it. If it is smaller than k, find it out rest of the elements. So how we are finding out rest of the elements? Until I is less than n and array of I is less than or equal to k I plus plus. So what we are doing is if we have traversed something like this, any of the elements, and if we reach to this, when our I is this, what we are finding it out is we are not updating I, rest of the elements we are traversing, and we are making it sure that these three are counted. 302 for k equals to 3. Understood? So to count this 3, we have written this kind of loop. For array of I, if it's greater than k, let's say over here it would be 8, we have removed it. When we reach to 3, for I equals to the same one, array of I is less than or equal to k. Until that time, I plus plus. So 3, 0 and 2, we incremented it and we made the count equal to 3. So far, so good. Understood this part of code?
Yes.
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 So what? Yes. So what will happen in this example, which I have taken over here? In this case, we will have take the count equal to 1. Okay. And then over here, again, we will increment the count equal to 2. So the count will happen 3. Again, we are making the mistake. We should not just make the count. What we need to do with the count, what are the number of subarrays? We need to find it out. And with this count, what are the number of subarrays? We need to find it out. And then we have to make the summation of those, right? If we take another example, as I say, 304, right? So we need to make sure for all, right? 30 and all, right? 30 and 12, all the subarrays, right? So we need to make sure of those. Simple. So our code was written up to this. Next step is to count the subarrays which can be generated from this. So if it is not greater than k, in this case only it is happening. So our count was previously set to 0. Now I have incremented it and then I found it out the total number of subarrays from that. So in this case, I have found it out the total number of subarrays from this 2 element to 3. And then I incremented, I incremented it, I found it out. And then again, when my subarray is pointing to, I is pointing to 4, my count should be equal to 0 because over here my count was 2. Now over here my count should be again 0 because I have to find it out the subarrays from this 2. So that's why I have written this count equals to 0. So for the next time my count will be 0, but my number of subarrays, I'm incrementing it. So number of subarrays, I'm incrementing it with this equation, count into count plus 1 by 2. Simple. So with this equation over here, we will make the count equals to 3, number of subarrays equal to 3, and then over here number of subarrays equal to 3, and we'll make the addition of it with the s plus equal to. And this should have been reduced from the final total one. So for the simplicity, it's a subarray I have taken, subarray plus equal to count plus 1 by 2. And I'm reducing it from the total number of subarrays, which is n into n plus 1 by 2 minus subarray, and this should be into the return statement. Simple one. And you can make a note of this code over here. This code is working.